current around the wires, he could see glowing patches between the wires. And with a bit of tweaking, he saw these glowing patches formed a pattern. The blue glow and electrical sparks occurred in distinct patches evenly spaced along the wires. He realized they were the peaks and troughs of a wave, an invisible electromagnetic wave. Lodge had proved that Maxwell was right. Finally, by accident, Lodge had created Maxwell's electromagnetic waves around the wires. The big question had been answered. Filled with excitement at his discovery, Lodge prepared to announce it to the world at that summer's annual scientific meeting run by the British Association. Before it, though, he decided to go on holiday. His timing couldn't have been worse, because back in Germany, and at exactly the same time, Heinrich Hertz was also testing Maxwell's theories. Eventually, Hertz found what he was looking for, a minute spark. And as he carried his receiver around to different positions in the room, he was able to map out the shape of the waves being produced by his apparatus. And he checked each of Maxwell's calculations carefully and tested them experimentally. It was a tour de force of experimental science. Back in Britain, as the crowds gathered for the British Association meeting, Oliver Lodge returned from holiday, relaxed and full of anticipation. This, Lodge thought, would be his moment of triumph, when he could announce his discovery of Maxwell's waves. His great friend, the mathematician Fitzgerald, was due to give the opening address in the meeting. But in it, he proclaimed that Heinrich Hertz had just published astounding results. He had detected Maxwell's waves traveling through space. "We have snatched the thunderbolt from Jove himself and enslaved the all-pervading ether," he announced. Well, I can only imagine how Lodge must have felt having his thunder stolen. Professor Oliver Lodge had lost his moment of triumph, pipped at the post by Heinrich Hertz.
Hertz's spectacular demonstration of electromagnetic waves, what we now call radio waves, even though he didn't know it at the time, is going to lead to a whole revolution in communications over the next century.
Maxwell's theory had shown how electric charges could create a force field around them, and that waves could spread through these fields like ripples on a pond. And Hertz had built a device that could actually create and detect the waves as they passed through the air. But almost immediately, there would be another revelation in our understanding of electricity. A revelation that would once again involve Professor Oliver Lodge, and once again, his thunder would be stolen. The story starts in Oxford in the summer of 1894. Hertz had died suddenly earlier that year, and so Lodge prepared a memorial lecture with a demonstration that would bring the idea of waves to a wider audience. Lodge had worked on his lecture. He'd researched better ways of detecting the waves, and he'd borrowed new apparatus from friends. He'd made some significant advances in the technology designed to detect the waves. This bit of apparatus generates an alternating current and a spark across this gap. The alternating current sends out an electromagnetic wave, just as Maxwell predicted, that is picked up by the receiver. It sets off a very weak electric current through these two antennae. Now, this is what Hertz had done. Lodge's improvement on this was to set up this tube full of iron filings. The weak electric current passes through the filings, forcing them to clump together. And when they do, they close a second electric circuit and set off the bell. So if I push the button on this end, it sets off the bell at the receiver. And it's doing that with no connections between the two. It's like magic.
You've got to imagine a packed house, lots of people in the audience, and what they suddenly see is, as if by magic, a bell ringing. It's quite incredible.
It might not have been the most dramatic demonstration the audience had ever seen, but it certainly still created a sensation among the crowd. Lodge's apparatus, laid out like this, no longer looked like a scientific experiment. In fact, it looked remarkably like those telegraph machines that had revolutionized communication, but without those long cables stretching between the sending and receiving stations. To the more worldly and savvy members of the audience, this was clearly more than showing the maestro Maxwell was right. This was a revolutionary new form of communication. Lodge published his lecture notes on how electromagnetic waves could be sent and received using his new improvements. All around the world, inventors, amateur enthusiasts and scientists read Lodge's reports with excitement and began experimenting with Hertzian waves. Two utterly different characters were to be inspired by it. Both would bring improvements to the wireless telegraph, and both will be remembered for their contribution to science far more than Oliver Lodge. The first was Guglielmo Marconi.
Marconi was a very intelligent, astute and a very charming individual. He definitely had the Italian-Irish charm. He could apply this to almost anyone, from sort of young ladies to world-renowned scientists.
Marconi was no scientist, but he read all he could of other people's work in order to put together his own wireless telegraph system.
And it's possible that because he was brought up in Bologna and it was fairly close to the Italian coast, that he saw the potential of wireless communications in relation to maritime usage fairly early on.
Then, aged only 22, he came to London with his Irish mother to market it. The other person inspired by Lodge's lecture was a teacher at the Presidency College in Calcutta called Jagadish Chandra Bose. Despite degrees from London and Cambridge, the appointment of an Indian as a scientist in Calcutta had been a battle against racial prejudice. Indians, it was said, didn't have the requisite temperament for exact